Okay, well, good afternoon, and thank you for joining us for the second session in the Data Management webinar series. My name is Nancy Leonard, and I'm moderating today's webinar. In case we haven't met, I work for the Pacific States Marine Fisheries Commission, where I lead the StreamNet program. PNAMP, along with StreamNet, have been co-leading the planning of this webinar series, and I'd like to thank the planning group, which included 13 people from a variety of organizations that work with us to pull together all the presentations you've been watching and attending throughout the past few months. We have some great data management talks lined up for our second webinar today. And I'll also remind you that next Thursday, which is our last data management webinar, we'll also have a couple of great data management talks starting at 1 o'clock Pacific time. If you want to receive additional information about PNAP events, you can join the monthly newsletter, and Amy, my colleague, will be dropping a link in the chat. If you don't know where to find the chat yet, don't worry about it. We'll be covering that soon. So just to give you a bit of orientation on our agenda, we'll be starting off with a bit of a practice run with an icebreaker, which I'll get to in a moment. And then we will have our first presentation, presenters, Kevin and Jeff from the USGS, presenting their talk on data visualization tools and framework for hazards and risk research. We'll have maybe a few minutes for questions before we move on to Brendan Ward from Astute Spruce, who will also be presenting on open source technologies to build spatial web apps. At the end of both of these presentations, we'll have a longer period for question and answers. And then you'll be able to pose any question that you didn't have a chance to pose to either of the two presenters or three presenters. So just before we get started, I'm going to give you a bit of tips for how to use the different functions of MS Teams for those of you that are not familiar with this meeting platform. The one icon that we really want to point out is the mute button. Now, depending on what version of MS Teams you're using, if it's the web browser or the desktop or an older version, the location of the bar may be at the top or at the bottom. You may have to move your mouse to make it appear, but the icons are all pretty much the same, regardless of the version you're on. If you're not using your computer audio, you can use *6 to mute yourself and to unmute yourself. The next tip, in case you're not hearing me at all, and all you can see is my mouth moving, if you're having problems with your audio, you can go up to the device setting. To get there, you click on the three little dots on the toolbar, go up to device setting, and then that's going to pop up the options for your headset and speak and microphone. If you're still having difficulty trying to figure out a function of MS Teams, you can drop us a chat in the chat box. This is the chat icon on the toolbar. Take note of this one because we'll be using this one throughout the webinar. And you can send us a chat, and one of the PNAP staff will talk with you to try and resolve the issue that you're experiencing with MS Teams. So the one reason we pointed out the chat button is because we'll be using that to get your questions that you want to pose to the various speakers that we will be having today. If you think of a question while someone is presenting, go right ahead and type it in the chat. And then when we get to the Q&A section, we'll go through the chat and pick up all the questions to make sure that we hit all of them. If you prefer to speak instead of typing in the chat, you can use the hand icon. Just click on that, and then the PNAP staff will keep track of the hands that are raised, and we'll call on you when it's your turn so that you can turn on your audio and ask your question. So we're going to do a little bit of a practice run here. We're going to be dropping a link in the chat box so that we can get you all oriented and make sure you know where to find that chat. It'll be a link to a live polling question using Mentimeter. It's just going to be a fun icebreaker, so you can just have fun clicking whatever answer choice you want. So Amy will be dropping that link in the chat. There you go. So the link is there. For those of you who can't find the link in chat and need a bit more time, you can also just bypass the chat for this exercise by going to this website and entering the code. So let's take a look at how the results are coming through. You up to 21, 22 folks. I'm just looking at the lower right to see how many people are coming in. That's a pretty good chunk. Let's see how we're doing. So the question, what was the last type of chart visualization you made? And it looks like we have two winners of those that have selected the scatter plot and or line chart and the map being the two top winners in terms of the type of visualization was selected by all of you in the last presentation you made. So this is just a fun way to get you oriented to the chat. Let's go back. Looks like most of you managed to find that. So now I'm going to be passing it on to Amy. Amy will be introducing our speaker. Amy is with PNAMP, and she's one of the planning group members that have been helping us organize all these webinars and making sure that they all run smoothly. So Amy?
Thanks, Nancy. And thank you everyone for joining us today for two very exciting presentations on data viz tools. So first up, we have Kevin Henry and Jeff Peters with the USGS Western Geographic Science Center. Kevin and Jeff research risk and vulnerability to natural hazards, and they work closely with state and community agencies and emergency managers to conduct GIS analyses that produce results to help plan for future hazard events. They have extensive experience using both open source tools and Esri's suite of web platforms to develop data visualizations, and will share some of their experiences using those tools with us today. Now I'm going to pass it over to Kevin and Jeff.
Hi, everybody. This is Jeff Peters. Can you see my slides okay?
Yes, I can.
Yep.
Assuming you can. Great. So Kevin will speak a little later, and we're going to show you some examples of visualization tools we've built for hazards and risk research. So our tools help deliver science results to emergency managers in an engaging and interactive format. We often talk with these emergency managers on what they'd like to see in these applications as we develop them. They also help display large data sets and complex results that are sometimes very difficult in a traditional publication or a static graphic. Interactivity helps engage with the information. And it also helps these users summarize and compare the results. And really, it helps them create graphics for specific scenarios and their planning documents and presentations. So we're going to be showing you quite a few, and it might go kind of quick, but I want to point out that the examples we show you use only pre-processed data. Some of them I get questions about, oh, is this data on the fly, or is it analyzing the data as you go? And that, in our case, it's not. We pre-process all the data using GIS and then serve it using these visualization tools. So here's an overview of what we'll be showing you and how I and Kevin, we like to categorize these platforms when we're considering which ones to use. So I fall into the no-code category. I'm not a programmer really, although I can program, but I'll be showing you some examples using Tableau and ArcGIS dashboards. And then we'll show you some examples that use some code, and that includes ArcGIS Web Map Builder, Web App Builder, and RShiny. And then if you're a real programmer and you want full customability and you don't want to pay for a license, you can go for our Plotly example and using Dash and Python, or a JavaScript and D3 full customization, which Kevin will show you. And my little graphic here is just to kind of show you the gradient of things you might consider when choosing one of these platforms. It's not cut and dry, and there is some gray area in between where you might need a license, but you may also have to serve it yourself. And I'm going to warn you all that I hear my leaf blower coming, so I'm going to shout. But now we'd like to get a sense of your experience using these platforms. And so Amy is going to share another survey link in the chat for you to tell us how you use these, or your experience using these. And I'm going to show the results now. Oh, and I should mention, if you don't have experience with any of them, just click submit. One is a fair answer. Okay, I think we've seen our results now. We've got a tie just about for ArcGIS dashboards and RShiny, and we've got a bunch of coders in the group. So I'm going to move on to the presentation and try to beat my leaf blower here. Presentation, there it is. So the first one I'm going to show you is an example using Tableau. It's one of the first ones Kevin and I built together, and it shows the evacuation results of our modeling. It helps emergency managers understand the number of people that may need to use up to 15 minutes to evacuate. And Tableau offers a standard interactive map, and it's handy to compare two spatial zones. We're using tsunami zones here. And our app also helps compare two separate populations. Tableau does allow you to sort of zoom into the map in certain specific places, as you see there. And the thing the emergency managers liked on this is everywhere you hover over it, it offers a custom message for them to use in their planning, rather than reading through a science document. So now I'd love to show you some screenshots of building something in Tableau, but unfortunately I don't have a license anymore, which is my first bullet. You need a license for Tableau, and I built this, I published it over a couple years ago, so I'm unable to log in and show you. But here's an example of why embedding in a website is handy. We were able to show some helpful hints on how to interact with it, some background, and some links to the published documents. The Tableau environment is a table-driven interface, and it does offer a lot of chart and graph options, but the mapping is very limited as of when I use it. I've heard it's improved, but we kind of worked around that using Mapbox, which allows you to make very custom base maps. So it would bring in our base maps. Okay, on to the next one. This is a story map, but I'm going to just cover up the story map part and show you the dashboard. And it's about California volcano exposure, and it's to help county emergency managers estimate the potential for volcano hazard exposure. And it's a very it's a more interactive map because it's an Esri product, and it helps compare the exposure of a volcano. You can zoom into different counties on the choropleth map and understand their percentage. And the real challenge with this one is I was struggling to fit everything on the screen. So you'll see you're able to hide stuff in this Esri dashboard and get the full picture, which I thought was really handy. And this one I was able to show you what it's like to build this. Here's one of the screens in the Esri dashboards, or ArcGIS dashboards, that is where you're selecting the options for the various graphs I used. And you'll notice there's no customization. You can't customize the colors. It's a sort of a canned product, but it's handy because you can serve it through Esri, and it does offer extensive mapping and many interactive connections between the maps and the graphs and various buttons and stuff. Kevin has even better examples for this. But the data in these Esri projects needs to be spatial somehow, although I think you could probably trick it using a workaround of some sort. But there is very, as I mentioned earlier, there's very limited graphic capabilities. So some people really want to customize everything, and you're not going to be able to do that with this. So next up is Kevin with another ArcGIS dashboard.
Yeah, thanks, Jeff. And so here we're using the same platform that Jeff showed before for his volcano project, but this is taking it at an angle of more of an exploratory analysis. So this was a project for, and Jeff, I'm not sure the video doesn't seem to be playing, but I can talk over it though, it's kind of supplemental. This was a project for Department of Interior for sort of facility managers, and there it goes. We wanted to work together to identify opportunities to kind of share a working space or share just kind of like building usage across different bureaus. And they didn't really know what they had available. They didn't know what the story was with the data. So I did a kind of clustering analysis, a GIS analysis that's part of that pre-processing side that Jeff mentioned. And then I put that data in there in these cluster formats into the dashboard builder. So it's super easy to put in geospatial data. It can also it can pull tabular data from that and then tie it back into the map. So you can use map for navigation. And that was nice for people to see, they didn't realize that other bureaus had facilities out here. We're looking at like Lake Mead right now, for example. And yeah, it's nice to be able to kind of click around and see relationships in this sort of exploratory analysis. In this case, yeah, identifying potential opportunities. The issue that we ran into is lots of these people wanted to see the raw data and they wanted to see it in a, they're used to Excel. They wanted to see it in a tabular format that they can sort, filter, and the Esri dashboard really fails at that, in my opinion. They don't have a good way. This list that you see in the bottom right corner is the best sort of tabular adjacent format for showing the data. And also it's not easy to download the data. So you can see in the bottom corner of the screen, there's a little teeny link where I said, click here to access the tabular data. And Jeff can go to the next slide to show a workaround that I used, which was just putting the tabular data up in a sort of JSON format and using open source web table tools to just create a very kind of basic Excel-esque table that was just a nice extension of the dashboard. After the user could maybe identify a cluster that they were concerned with, they can then go into this supplementary app and pull out the data for download and manipulation. So you can go to the next slide, Jeff. So we're going to change gears and stay in the Esri world, but move into more complex web apps. So this is the ArcGIS Web App Builder. And it's sort of a one-stop shop for creating, various scales of web maps. A lot of cities and counties will use this for their sort of catch-all GIS portal. We're using it for, in this case, a rapid response tool for hazard and emergency planning within the Department of the Interior. And the nice part about the Web App Builder, it has a huge suite of already created sort of widgets that can do all sorts of map-related tools, even GIS analysis. So in this case, we're using what Esri calls a screening widget, but it's really just kind of doing an analysis of saying, all right, I want to know what assets are within Yellowstone National Park in this example. And it gives you just a nice list of everything. And this is the only example we have of analysis being done on the fly, which is nice. So it kind of can help create a sort of user-centric experience. And I think I'll show, yeah, here the user is kind of drawing their own area of concern. So we couldn't really get this with pre-can data, but in conjunction with the user supplying an area of interest, we can give them just the sort of data that they're interested in. So you can go to the next slide, Jeff. Yeah, and this also demonstrates how it can be customized further. So this is ingesting other web services into the app to see. This is just like a constantly updating weather data set that's not managed by us at all. We just can kind of link to it, and the user can curate their map how they like and see. This is a tornado, I think, outlook. We can provide a list of these that we've found, and then the user can also upload their own content from ArcGIS Online, or even upload different web services. So, I mean, and this was done with out-of-the-box widgets and technology that Esri supplied. So it's pretty powerful and falls in that realm of you don't need any programming expertise. But if Jeff moves to the next slide, I can show that you can certainly flex your programming muscle if you'd like. So this is another app within the same project about DOI risk to DOI assets. So we had a very specific story we wanted to tell. We had a big sort of data analysis project from other members of our team that was identifying the exposure of, I think, 37 different categories of assets to 74 different types of hazards. You can see there's quite a range here as I zip through the app, but we want the user to be very specifically guided through kind of step by step to identify their asset of interest, and then they can go and they can see the hazard exposure in a nice little visualization that I was made with D3, and then they can go in and add supplemental map information. In this case, they're in Yosemite. They identified it has high wildfire risk, and then they can add in the actual spatial data, and then they can interact with the map to manipulate it, and then just kind of get at that information in a more digestible manner than just looking at raw GIS data. And they don't necessarily need GIS experience. The sort of drawbacks of this, there are two kind of main widgets I have here. The widget being displayed now I made custom, which was relatively straightforward for someone with my knowledge of programming. And the other widget, which lets you add data and manipulate it, I had to modify Esri's existing widget, which I've learned it can be sort of a confusing process because the code base is relatively arcane and there's not a lot of good documentation. So it can do whatever you want, but you have to budget in extra time and headaches if you really want to sort of bend it to your will, which can be done, but again, it's difficult. So I think I'm ready for the next one. Yeah, so this is, I have a little video of myself going through and demonstrating the non-programming side and the nice kind of GUI interface of modifying and creating your own web app. And this is the sort of config panel for my own app I just demonstrated. And it has all different sort of functions from cosmetic, colors and themes, and you can actually add in another widget from Esri's big suite. So I'm just showing here a big page of all the different options. Printing widgets, analysis, even basic things like charting. And, I'll go through here. Now you can even add just very, simple HTML widgets. So this is a useful kind of tool. With our intention was to hand off to other sort of information managers or GIS teams if they wanted to add data or modify data, and it helps the kind of project persist, and you don't need as a programmer necessarily to be managing it, maintaining it for the end of time, because it does have this framework that lets it be easily extended and small tweaks be made to it. Okay, thanks, Jeff.
You're welcome. All right, I think I'm going to quickly just show off this land carbon app. Again, I didn't create this, but it's made using RShiny, and I'm impressed. So I thought I'd show it off. It compares carbon storage estimates for different climate change scenarios and ecoregions. And you can choose a map or choose an ecoregion in the map You can graph the storage estimates by different vegetation types, and you can change the climate change scenarios there and focus on different vegetation types for the graphs at the bottom there. And here comes that leaf blower. So since you guys know our shiny well already, and I'm about to get drowned it out, I'm going to let Kevin go on to the next one.
Thank you, Jeff. Yeah, in keeping with the spirit of work from home, I have a visitor cat joining us as well. She's must have heard the leaf blower. Yeah, we're moving on to more of the custom end of things. This is we call it just a dashboard, but it's very kind of tabular data driven. It's again part of this bigger risk to Department of Interior assets that we're working on, and the users needed a easy access point to get at the kind of raw data, the numerical data, and also just understand it in a more streamlined way that was catered toward the data sets they actually needed. So a colleague of mine developed this with Plotly and Dash. These are modules that are written in Python language, and it creates a full sort of like server side website that you can totally customize to have it look the way you'd like. And I see a question from Lisa. Thank you. We will provide a link to all of these apps that are shareable, and I think Amy will have that posted in the chat. This is customizable. You can manipulate the data however you like with Python. You don't have to wrench it in, as I call it, into other existing frameworks. And the only sort of drawbacks are that, yes, you do have to have this Python programming knowledge, and you do have to have some sort of server infrastructure for this, because it does need to run on a machine that is then served via some sort of web server. But it's free and open source. There's no cost to any of these, and again, you have large control. It almost acts like it's sort of Tableau, like the way we've set it up, where you can filter based on your selections of different categories that we felt were important. Here we're showing museums within the Columbia Pacific Northwest region, and then the user can see it. They can see more graphs, and then they can also just download the data to manipulate how they would like to. Yeah, Jeff, you can go to the next slide. So an important thing that we hadn't exactly talked about, and Tableau and these dashboards have been around for a lot, so people may have already have a good grasp of this, but pre-processing the data is pretty crucial. A lot of these applications and dashboard builders work with the idea of like database schema, have tables in mind, rather than kind of the more Excel and human familiar format that we're used to working with. So the Tableau here, I took some screenshots from their guide to getting your data ready. This Dash works the same way, and you're just kind of tweaking columns. Oh, there it goes. And adjusting, adding columns, adding attribute information to different rows, and that's all done with pandas in this, which since we're using Python, that seems to be the go-to sort of data manipulation framework. So yeah, Jeff, you can go to the next slide. And yeah, I think we're going to end our examples here with the most custom that we could find, and it's sort of the biggest project that we've undertaken, I think, certainly from my end, which we had a very specific goal and sort of data set in mind. So we're presenting societal exposure to sea level rise in California, and this is geophysical modeling that was done by some of our other colleagues in USGS, and then we took socioeconomic data that performed more GIS analysis on top of that, and then we have very specific sort of stories we're trying to tell with our visualization. In this case, it's showing you the census block level exposure, in this case residents to sea level rise, for a very specific scenario. I think we started with 44 different scenarios with a combination of coastal storm, return interval, and sea level rise. So there's lots of different combinations of data here. and we required kind of a more powerful custom approach. So we had about 3 people that have been working on this, for the better part of maybe a third or half of the year for the last 3 years, working on database preparation, coding, GIS analysis, and these main visualizations are done using D3. Other JavaScript libraries such as data tables is presenting this tabular format. And in order to do this justice, we went full in on the cloud infrastructure side. So we were one of the first I think we were the first application in USGS's new cloud hosting services infrastructure. So that uses Amazon Web Services, and we have a full stack with a web server, a geospatial server, and actually, Jeff, you can go to the next slide. And forgive me if this is a bit mind flooding, but we have a lot of different clouds and different arrows and different data going in different directions. So this is kind of what it takes to create a custom app that's totally, what the scientists want to see, and how we can get the data presented to the public and stakeholders in the most digestible format. So there's lots of pre-processing and things happening with Python, and then the main bulk of visualization was done with Leaflet. Charting was done with D3, and then we created a full custom HTML wrapper, mostly using Bootstrap. And yeah, again, all this is in the sort of Amazon cloud environment. So I think that's what I have to say for that. Yeah. And yeah, I don't know, Jeff might want to jump in too. We have a lot of final thoughts and lessons learned, so I guess I'll let him start, take a quick breather.
Yeah, now is when we get to try to talk over each other. I'm looking at the clock in the corner of my thing, and it looks like we're way over time, but I'll let Amy tell us when we're done. But you may have noticed that we use the word workaround a lot. And that's because if you look back at the various choices, the third slide I had about the things you might consider when you're choosing one of these platforms or frameworks, there's always a compromise. There always seems to be something you want out of the one you chose that you can't have. And so we call that workarounds. The one example I used was Tableau's maps just weren't doing it for us, but we found that Mapbox base map, which is free, and you can create very sophisticated base maps, which got the job done for us. It looks like the map's part of Tableau, but it's not really. Some of the other example I showed is we used Esri story maps to organize all of those dashboards. I only showed you one for the volcano example, but there's actually 8 in there, and that one is publicly available. You can get the list out of the chat and go check it out. But that one, I used several story maps stacked on top of each other to create the tabs and the organization, the structure of the whole thing, instead of just having individual Esri apps. They're all stacked on top of one another. So that workarounds was really my final thought, and that there's always a compromise. You can never seem to get out of these things what you want unless you have a huge team of talented coders. But nothing else is coming to mind right now. You got anything, Kevin?
I can talk more about, like, another example of the workaround is with the ArcGIS dashboard. I have all these, like, have an entire hidden panel of these behind the scenes numbers and codes that, as we program them to be interactable with the user, but I have to hide them because they're like turning levers and pulling levers, turning knobs in the background to make the app do exactly what the sort of stakeholder wanted it to do. And even the custom table thing that I had to make is kind of like a workaround because Esri doesn't have that functionality in their app. So I had to give some sort of tabular presentation of the data. And I think one of my biggest lessons learned is, as someone with a bit of programming knowledge, understanding this kind of, there's a middle ground of taking a framework like the web app builder in this case that is marketed as extensible, and technically it can be extended. And I've worked with other open source tools as well that have a similar marketing, but in the end, the amount of work and headaches that are required to tweak it to the way you'd like it to, you at the end of the project, you're kind of just scratching your head thinking, oh, I probably should have just done this custom from scratch, and it would have been a lot easier for me, and we could have got what we wanted out of it. So there's always that kind of attempt to try to budget at the beginning of the project, maybe, and keeping those things in mind, where the marketed as the catch-all for everything that you can also customize to have you make it how you'd like it is not always as sunny as they market it as. And yeah, I mean, my timer, I think I might have like 30 seconds left, so I don't know if you have anything else to add, Jeff. I get one thing I'll say is the sort of managers or stake people that are trying to make decisions, I need to learn to kind of stand up to them sometimes when you're trying to work with these rigid frameworks as well. Sometimes people can think that the sky is the limit, but you got to keep yourself a bit grounded sometimes.
Yeah, sometimes you just have to say no when you know something is not possible or not within the budget. But looks like we got a question here. How much learning is needed to operate in the cloud environment? Which is a perfect, I was going to mention as my final thought. I tried to show on my slides where I'm able to serve these applications or dashboards. And a big selling point for the ones I built was we didn't need a cloud. The Tableau and ArcGIS Online can serve these things for you, and you can style them a bit in an HTML website. And so for the stakeholders I was working with, that worked perfectly for them because they didn't want to pony up money for the people who knew how to use the cloud. And I'll let Kevin comment on how much learning is needed because I have never actually used the cloud.
Yeah, I can comment on using AWS. I haven't used Azure or any or Google's cloud services, but there's definitely going to be a sort of learning curve regardless of what side you're coming at it from. So our team, and I think a lot of other people have experience working on like a local machine or a server, and then you're fine running the server side software and code to get your app up into the internet. But yeah, we had to learn quite a bit of just interacting with AWS, all the lingo and different things to set up, even just a simple virtual machine to host it. And then there's all these other security and functionality on top of it. Like I think Amazon has something like 90 or maybe even more, 200 different little like sub tools on AWS. We use like 2 of them. We use the EC2, which is the server, and RDS. And from USGS side, thankfully, our team's cloud hosting services has been very useful about kind of holding our hand through a lot of the process. But at the same time as well, there's a lot of restrictions too that it was just kind of a learn on the job for us. But I would say it took the better part of 6 months mixed with development, but to get the actual kind of environment on the cloud running. So it is a considerable amount of work, but there's many resources that will do a lot of the sort of back end work for you potentially. It depends on how the structure is set up in whatever your organization is.
All right, guys. Thanks so much for information-packed presentation. That was great. I think we're going to move on. There will be time at the end. If you didn't get to ask your question of Kevin and Jeff, there'll be time at the end.
Also, email us if you have more questions. I love to chat.
Yeah, and so you can see their email addresses here on the screen. And then I also put that resources list link in the chat. You might have to scroll up just a little bit to get to that. I'll throw it in again at the very end of the meeting. But yeah, that has their email contact information as well. All right, thanks, guys.
Thank
All
you.
right. So up next, we have Brendan Ward. So Brendan combines a background in landscape ecology in software development with a passion for open source software to create geospatial web applications that empower users with the best available data. Brendan led the development of DataBasin during his tenure with Conservation Biology Institute, which has become one of the largest conservation-focused spatial data sharing and visualization applications. He now leads his own business, Astute Spruce, and works closely with government agencies and nonprofits to create web applications that enable them to better engage with their stakeholders for better conservation outcomes. So over to you, Brendan.
Thank you, Amy. And everyone, please let me know if you can't hear me or you can't see my screen, but otherwise I'm going to plow ahead. Thanks for having me here today. I'm really excited to share some of the ideas and approaches that have been successful for me in delivering spatial web applications around natural resource data. To help us recalibrate from the prior talk, my focus is going to be entirely over on the custom end of the spectrum. I build highly customized applications that are specifically adapted to a particular suite of data and the audience we're trying to empower. Or put differently, I am the workaround. These leverage open source components and a good bit of custom coding to glue them all together. My goals in this talk are to inspire you to use open source components, to highlight some of the approaches that have been useful for some of the geospatial apps I've been developing, and provide some ideas on how to engage with the open source community. First, I'm going to give you a quick overview of why I think open source is useful in this space. Next, I'll go through a few of the common building blocks that I use in my applications. And then I'll use a few practical examples to illustrate some new approaches that I think are exciting and very useful in this space. I'm going to keep it fairly high level today. I'm definitely not going to show you any code, but if you're interested in learning more about anything that I mention here, please get in touch. We'll also have a list of links and resources at the end of this talk and available on the webinar page and in the chat toward the end. So first, let's start with a definition of open source. It can mean a lot of different things to a lot of different people. So for this talk, we'll take it to mean source code that is freely available to view, which may also allow you to redistribute it or modify it. Often, this also means that it's stored in an easy-to-access central location, such as GitHub, GitLab, Bitbucket, or some other software sharing platform. However, even though you're free to view the code, how you use it is typically governed according to the software license provided with that code. And there are a wide range of licenses, ranging from restricted, where you cannot modify certain parts of the code or make modifications that compete with closed source from that same developer, to permissive, which generally allow you to modify and include that source in your commercial products. Others may require you to use the same license for redistributing your code as was used in the code that you're using. Always check for and review the licenses, and especially if you are building a commercial product on top of them. There's a wide range of motivations for creating open source, ranging from hobbyist projects created by developers in their free time to highly advanced software platforms created and controlled by corporations. Some may create open source projects to promote integration with a larger closed source platform. Other projects become foundational building blocks to a wide variety of end user applications. Open source is also related to the idea of working in the open, or putting your methods out there for others to read, learn from, adapt, and so on. One of the most powerful attributes of open source is that it preserves open knowledge. This allows you to learn directly from the code, both how a given problem was solved or could be solved, how to write better code to solve problems more effectively within your own code. You can also review the code to determine whether you should trust it and whether it's appropriate for your particular use case. Another great thing is that by using open source components, it makes it easier to share your own solution in a way that others can use, learn from, adapt, or run themselves for reproducibility. One of the reasons that I really like open source is because it gives you flexibility. You're not stuck in a box of a commercial provider solution. You can combine a wide range of different parts together to assemble a particular application. You also aren't limited to using a closed source or fee-based ecosystem. In some cases, It's also easier to try out cutting-edge approaches because you don't have to wait for them to be integrated into an existing commercial product. Building with open source also comes with a few challenges. One of the biggest myths around open source is that it's free. And while it's usually free to use, there may be substantial effort required to put together different building blocks into a full application. It may be substantially cheaper in the long run compared to a commercial solution, depending on where your costs are. You can scale it up without needing to pay additional licensing costs. And you aren't forced to upgrade your application as the commercial vendor replaces existing products with newer and different versions. The perception that code is free and yet should meet all your needs sometimes creates an imbalance between code users and code creators. Remember, they don't work for you. You may be deriving a lot of value from their project, yet you're not compensating them for their time. So please keep this in mind when interacting with open source projects. Be gracious, be grateful, and try to offer solutions instead of only problems. Also, always look for opportunities to help out with the projects you depend on. One of the biggest challenges with open source is around documentation. Sometimes it's pretty limited, largely due to scarce resources during development. The open source community as a whole recognizes this barrier to adoption and is actively working toward improving documentation, especially as projects become more popular. This can also be a great way for you to help out. If you keep track of the challenges that you run into while you're trying to set up one of these projects, consider sharing that back to the project to make it easier for other users down the line. One of my biggest frustrations in open source is running smack into the walls that commercial entities build around their proprietary ecosystems. And this is certainly true with geospatial data. While there may be file formats that work great in these closed ecosystems, they may be totally inaccessible on the outside because they're either undocumented or have limitations around their use. This leads to using an entirely different set of GIS formats in open source geospatial libraries than in those commercial ecosystems. And this is partly why the shapefile format, which is nearly 30 years old now and pretty limited, is still alive and well in the open source ecosystem because it was released early on as an open specification. I'm now going to transition into discussing some of the building blocks that I use in my applications. My approach to building an application starts around a few common goals. I'm ultimately trying to create more opportunities to engage folks with the best available data and science. By making it easier to engage with data, my hope is that this helps users have more impact in their respective domains, such as more effectively planning land acquisition or targeting aquatic barriers for removal. I've also found that it's better to start as small and as simple as possible to establish successes early and get buy-in from constituents. This allows us to iteratively make those projects better based on real-world use and feedback, rather than over-engineering that early on. I translate those goals into a technical approach by specifically trying to use the fewest number of moving parts and make things as simple as possible. And by simple, I don't mean dumbed down. Instead, I mean that the core workflows should be easy and intuitive to perform, and that the technologies that provide those are not complex to assemble or maintain. This helps us keep our maintenance and our operating costs down because we are using the fewest number of moving parts that might break. One of my core approaches is to try and do all of the slow work in advance. This often involves a lot of data processing and transformation so that once those data are presented in the application, they are in a distilled and easier to use form. Ultimately, we're trying to go from data to user engagement. And today we're talking specifically about web applications that run interactively in a user's browser. These usually include informative content and interactive elements such as maps or charts that allow the user to engage with and explore the information. And where I can, I try and bake in at least some of the data directly into the application so that in your browser, things load and display very quickly for users. Depending on the project, this may be limited to some lightweight summary data that we display on the homepage because your homepage should always load quickly. Or it may include some or all of the data that you display throughout the rest of the app. I always have to do a good bit of data preparation in advance in order to make this possible. In the applications I'm going to talk about today, they include interactive maps against fairly large spatial data sets. Since that data is too large to live directly within your browser, we use map tiles. We render these in advance and we host them on a lightweight tile server. And sometimes a particular app needs access to more data or functionality on the back end than is directly available within the browser or the map tiles. I'm going to drill into each of these in a little bit more detail. In terms of browser apps, until a few years ago, the common way of building a front-end app was to use an instruction-oriented approach. You had to provide a set of instructions that would update the view for the user when the data changed or the state of the application changes, such as loading an area of interest. This is the approach that's used by D3, unless you're using one of the newer frameworks built on top of it. Lately, I've been using a framework called React. React and other frameworks like it instead let you declare what the final presentation should look like, almost like a template, but with a lot more flexibility about how you compose the flow of data into that presentation. This streamlines going from data to presentation within the browser. And it is often this step of updating the presentation based on new data or a change in the application state where apps become increasingly complex and harder to maintain. To make things even faster in the front end, I use what is called a static site generator. Instead of having a web server dynamically assemble a web page and ship it to the front end each time you visit a page, the static site generator creates all of those pages in advance, and it optimizes them so that they render quickly in your browser. Where possible, we bake the data directly into this static site so that individual values are displayed directly in the content of the page, or they're shipped along as small data files that are used to power some of the dynamic elements that we have within the website. For the applications that I'm going to show you today, the data are not released very frequently, which makes it a lot easier to bake in data. For data that change more frequently, you have to take a different approach depending on your goals. You can still generate the entire front end in advance using a static site generator, but load the data over an API that gives you the freshest data. But it may be a little slow because rendering the page depends on going out to that API and fetching the data in addition to fetching the page. Or you can build the entire application with the data on a recurring basis, say every night, or trigger that as the underlying data change. One of the things that I like best about using a static site generator is that it simplifies your hosting. The output of this is a simple set of files that you can host on any web accessible file hosting. And this type of hosting can be free or very cheap compared to operating a more complex web server that needs to be running all the time and accruing costs. On the data prep side, I use Python to build data pipelines that transform the raw data into optimized data structures that can be used in these applications. It has a rich and growing data science and geospatial ecosystem, and it's been growing in some very exciting ways in just the last few years that I'll be talking about more in a little bit. One of the nice things about Python is that you can directly share the code for your processing steps for reproducibility. Compare that with data pipelines that you assemble using proprietary tools in a closed ecosystem that you can't even view or share outside of that ecosystem. Many of my projects involve interactive maps, and for these I use front-end libraries like Leaflet or Mapbox.gl, and I consume map tiles. These are all made in advance rather than dynamically as you're interacting with them in the map. And they come in two basic types. First, we have image tiles, which are a picture of the data, and we have vector tiles, which include geometry data, such as points, lines, or polygons that have been cut up according to a tiling scheme and shipped to the front end with their associated attributes. These are rendered dynamically in your browser, which makes them incredibly powerful for interactively styling or filtering them. One of the things that I really like about using the tile approach is that they're very simple to serve. You don't need a full GIS server. I've been using a very lightweight and fast tile server I created a few years ago called MB Tile Server. There are lots of others as well. This one is super easy to install on the smallest possible servers in AWS, which keeps our costs down. Sometimes you need more data or functionality that you can bake into a simple front-end application or in the map tiles. And in this case, I bring in an API tier. There are a lot of different ways of building out an API, and how you do it should be tailored to your operating environment, the specific needs of your app, and developer productivity. I particularly like a Python API framework called Fast API. It's very well documented, easy to set up, and one of the fastest available. It works great for setting up custom APIs backed by data files, like generating a report for user-defined areas of interest. Depending on how you're using your data, a newer approach called GraphQL makes it easier to build out dynamic APIs that let you query your data from the front end in a lot of different ways. Among other things, this makes it easier to build out the front end of an application. Whereas traditionally, you had to build out separate API endpoints for each type of data that you wanted to query, and then glue that all back together on the front end. So next, I'm going to switch to showing some practical examples of using open source and some newer approaches for building geospatial web apps. The West Coast Estuaries Explorer was built in partnership with the Pacific Marine and Estuarine Fish Habitat Partnership and the North Pacific Landscape Conservation Cooperative during my tenure with Conservation Biology Institute. The data was led by Van Hare and Brett Holycross and Kate Sherman at PSMFC, and I know at least a couple of you are on this call, so shout out there. It showcases some of PNAMP's new data on the extent of estuaries and the state of the knowledge on how key species use those estuaries. It's intended to be a fairly simple application focused on information discovery and exploration. One of the things that makes this application unique is the ability to filter estuaries based on different characteristics, while at the same time providing quantitative summaries about how many estuaries have those characteristics. For example, what's the size distribution of lagoonal estuaries? To do this, we use an approach called dimensional filtering, which allows us to easily explore combinations across the input data. To do this, we use a JavaScript library called crossfilter to implement the internals of dimensional filtering, and we build out our custom user-facing widgets on top of this. There are other prepackaged libraries that sit on top of crossfilter that have some interactive graphics built on top of it. I found those very limited, and so I ended up building my own for these applications. Each characteristic that we want to filter on is a dimension within the data. For example, the type of estuary. And each dimension has a range of values. For example, an estuary type could be lagoonal or embayment or riverine. And it may have one or more of those values depending on its type. So species could have multiple values for a particular estuary. And then we define how we want to tabulate those up. In this case, we're tabulating it up based on the number of estuaries, but we could also do this based on area. The filters are additive within a single dimension and combinatorial across dimensions. This makes it very powerful for the user to find their own custom slice through the data and interactively explore different quantitative relationships within the data. We'll be expanding this particular application in the next few months to include nearshore habitat information linked to the estuaries. The Southeast Aquatic Barrier Prioritization Tool was created in partnership with the Southeast Aquatic Resources Partnership to allow users to find and prioritize aquatic barriers for further investigation and potential removal or mitigation projects. It's the primary outlet for SARP's regional inventory of dams and road-related barriers for 14 states across the Southeast. And it's compiled from national, state, and local information, and it's supplemented where possible with local reconnaissance to characterize the dams and estimate their social feasibility of removal. The primary goal of this tool is to find barriers that are feasible to remove in a given area of interest. While barriers are compiled regionally, they're prioritized locally. There are many large reservoirs and hydroelectric facilities that are unlikely to be removed, so it's important to filter these out early on and not spend any further time on them. There are also many barriers that have been created over hundreds of years that have fallen into disrepair or are otherwise no longer needed. And some are downright hazardous. So there are opportunities to remove dams that are not only hazardous, but also restore aquatic connectivity. To support that, the tool enables a two-step process to help users find and prioritize feasible barriers. First, you use a series of filters to identify the dams you're interested in and able to act on. And we use dimensional filtering here too. This includes information from local partners about the social feasibility of removal, characteristics of the dams from various databases, such as height, and results of the aquatic network connectivity analysis, such as the length of the aquatic network that would be reconnected by removing that dam. Once you've narrowed down the set of dams that you're interested in the specific spatial area you're interested in, the tool provides a simple ranking of those barriers according to different metrics of connectivity, including the length of the river network that would be reconnected, the overall percent of natural land cover in the upstream floodplain, or the complexity of the upstream aquatic network. You can then download these barriers for additional analyses and investigation. It's important to note that this is not an optimization process. It doesn't tell you specifically what barriers to remove or in what order. Instead, it helps local groups plan further investigation and outreach to identify candidate projects. We're currently working on expanding this approach to include 11 more states in the plains and in the interior west this year. The filtering, ranking, and data exploration in this tool is based on an analysis of aquatic connectivity that we run in advance. That's based on the National Hydrography Dataset high-res version that is then cut up based on the locations of those dams or other barriers. The precursor to this was built in ArcGIS based on around the medium resolution data and simply couldn't scale up to the volume of data in this high-res dataset. It would run for days and crash without completing the analyses. And I'm sure nobody else here on the call can share that kind of pain. I ended up completely rewriting the analysis in Python and can now run the connectivity analysis across the entire Southeast in just a few hours. The essential part that makes this scale up is using a vectorized approach everywhere possible. A vectorized approach basically means applying an operation to an entire column of data at once, instead of individually for each row within the dataset. When we're dealing with large data sets, we're always looping over multiple bits of data. The part that makes vectorization fast is where those loops are run. Interpreted languages like Python are really nice for writing data pipelines because the code is fairly easy to read, and you can interactively explore your data as you're writing your code. However, loops in Python are slow. In contrast, compiled languages such as C or C++ can be very fast because they're compiled to machine code in advance, but they're a lot harder to write. With vectorization, we try and reduce each operation in our pipeline to a fairly simple step and then do the looping in that operation in a compiled language. To give you an idea of what this looks like, we pass a column of data from Python, do the operation in a compiled language, such as multiplying all of the values by 10, and get back the results. This can speed things up by orders of magnitude, depending on what we're doing. In Python, the NumPy library provides a lot of optimized, vectorized operations out of the box for arrays of data, especially numerical operations. But working with raw NumPy arrays is not always very convenient, especially for structured data. So there's a library called Pandas that provides a tabular data structure, kind of like a spreadsheet, for working with data. It uses NumPy under the hood, so you can apply vectorized operations easily to entire columns of data. And it's also easy to go to and from tabular file formats such as CSVs or Excel. GeoPandas is a library that takes pandas and extends it to handle spatial data types and operations, and can read and write GIS file formats. It uses a fast geometry library under the hood called GEOS, but historically, GeoPandas has been kind of slow because it did a lot of the loops in Python. It's currently in the process of moving to a more vectorized approach, and certain things have been getting a lot faster lately. There's a new library that I'm super excited about called PyGeos. It uses the GEOS geometry library under the hood, but it uses an entirely vectorized approach for working with geometry data, such as points, lines, or polygons. And this makes it very fast, and also makes it easier to build out vectorized workflows on top of it. I've been using this for all of my recent projects, and I'm super happy with it. It continues to get better all the time. Using a vectorized approach requires thinking about the processing steps a little bit differently and can take a bit of getting used to, but I've been finding it to be a very powerful paradigm for scaling up geospatial and tabular analyses. The South Atlantic Conservation Blueprint Simple Viewer was created in partnership with the U.S. Fish and Wildlife Service as a tool to engage users with their regional conservation blueprint. The goal of this app is to enable users to easily explore the conservation blueprint and get a better understanding of why a given area is a high priority compared to another. It's an entirely data-driven product. It is based on several landscape level indicators that measure different characteristics of terrestrial, freshwater, or marine areas. These are fed through a complex model and connectivity analyses to arrive at the final blueprint priorities, but we want to enable users to see the underlying indicator values that contribute to certain areas being a higher priority or not. The data are all developed at a 30-meter resolution in the latest version. And in order to help folks better understand the drivers of the blueprint, we've been working on a pixel drill down version. Previously, we provided summaries at the sub-watershed level, which we prepared in advance. You'd click on the sub-watershed, you'd see summary data, and that would give you some information about what was going on in the landscape. But many users needed to step that information down to a finer level of detail. We wanted them to be able to click anywhere on the map and immediately drill down through the stack of all of the indicators and the final priority. The traditional way to do something like this is to have a GIS server and an API to query the data by location. You'd click somewhere in the map, send a request out to your server, wait around for a while, get the answer back, and display that to the user. I really wanted to avoid using a GIS server for this project for a lot of reasons. I wanted this to be as simple and as fast as possible. And so the key idea was to leverage things that we already had. We're already using a tile server to view the blueprint tiles within the map. Remember how earlier I said image tiles are only a picture of the data? Well, it turns out you can actually store a lot of data in that picture and reconstruct that data in the front end. This means that when you click on the map, we can show you the details right away because we already have everything in the front end. Your browser already knows how to decode image data, so we just needed a way to encode the data in such a way that we could pull it back out in the same way on the front end. For a single layer, this is pretty easy. You could just use the colors directly. For multiple data layers, it's a bit harder. You first have to stack up and encode all of those data layers into pixel colors, and then reverse that encoding in the browser. Basically, to a computer, a number or color is just a series of numbers, and a number is just a series of bits. So what we did was assign each data layer or indicator a certain number of bits within this series and stack them up. In our case, our data are simple categorical values, so each data layer only needed a few bits to hold any possible value. Once we stacked these up, this gave us the color value for that pixel. We used, on the back end in Python, a library called Rasterio to work with raster data files and NumPy to do this encoding as a series of vectorized operations. We applied this to all of the pixels and all of the data layers, cut them up into tiles, and tossed those out on our tile server. These are displayed in the front end as transparent data layers, so they're not coloring up your map, but your mapping engine is automatically fetching all of the applicable tiles for you as you pan or zoom within the map. You click on the map, we then drill down into the appropriate tiles, and we grab the colors from those pixels that you clicked on. We then extract the bits from that color, and because we know the order of the layers and the number of bits per layer, we can extract back out the value for each layer in that stack. And so the result is that we're able to query a whole stack of raster data directly in the browser, just using simple technologies like our lightweight tile server. We're currently building out a similar application on the same approach for a conservation blueprint that spans the entire Southeast and planning to release it in the next few months. This Southeast-wide blueprint brings together much more data from across the region, splices together several regional level or sub-regional level blueprints and conservation priorities, which makes it even more important to allow people to easily drill down into what's driving the priority for a given location. So with that, I'd like to wrap up what we went over today. First, I gave you my take on why I think open source is useful in this space. I talked through some of the common building blocks that I use in my overall architectural approach. I highlighted a few examples of some open source components and approaches that I use to build geospatial web apps. I hope that this talk inspires you to consider open source for a future project, and at least inspires you about what's possible. Thanks again for having me here today. And for those that are interested, I'll just leave my splash screen here with the frameworks and technologies that I mentioned earlier. We'll also provide links to those.
All right. Thank you so much, Brendan. That was a super interesting presentation. I have dropped that link for your resources list into the chat, and we'll go ahead and open it up for questions. So as a reminder, you can type your questions into the chat, or you can raise your hand and we will call on you to unmute yourself. Do we have, let's stick with questions for Brendan to begin with, and then we'll open it up for any questions. All right, so from the chat for Brendan, how much ongoing maintenance is there for customized tools?
That's a great question. It's very specific to the particular project and dependent on the technologies that we're using. If the data don't change and our technology stack is very small, we don't end up having to do a lot to maintain it over the course of several years. The caveat to that is everything that I'm showing here is browser-based, and browser technology is changing all the time. And that's usually the way I would describe it. It's kind of like being on a treadmill. And when you're actively working on your project or maintaining it, you're able to keep pace with that treadmill. The moment you stop, you have a certain amount of time before you fall off the end of that treadmill. Browsers are kind of like that, in that we can build a very lightweight, simple application that data don't change, nothing about the functionality of it's changing, but in a few years, the browsers are going to break it up on us. And so at minimum, there's a little bit of maintenance work required to keep up with what might be breaking from the browser side of things. What I've been seeing over the last decade or so is you usually get about 5 or 6 years out of that. The thing that changes more frequently is that the needs of your users change or the data change. And sometimes that means going back and heavily modifying the application or building a new version of it completely. In the JavaScript space, there are new frameworks and approaches that are coming out all the time. And once they mature, sometimes those become the best way to build something. And so what I've been seeing is some of my apps that we built in starting like 2014, we ended up going through a major rewrite of those in the last few years to adopt those newer frameworks. Partly because those let us bring in the newest data easier and also bought us a bit more time before we fall off the back end of that treadmill. For more complex apps, it's kind of proportional to the number of moving parts. You know, every server goes down at some point, every database flakes out on you, and so the more of those that you introduce to glue together into an application, the more of those you kind of have to get in and fix on a recurring basis.
All right, thanks, Brendan. Why don't we just go ahead and open it up? Questions for either presentation. And again, you can put those in the chat, or if you're not as shy, you can click that hand icon on the toolbar and ask the question yourself. All right, it's a pretty quiet crowd today. Oh, here we go. We've got something in the chat. I would like to know how they all rate R Shiny. That's for all the presenters.
I'm going to jump in because I was impressed with the app that I showed you and what it does, and I'm somewhat familiar with R code, so I understand what that entails. I can't remember if I mentioned R Shiny offers a Linux server for you to serve those from now, which was the one thing that I would have thought would have prevented me from trying it. So I'm actually looking for a project now to try R Shiny.
I would add that I think it's pretty powerful. It can create nice looking visualizations, and it's especially for like maybe a scientist side that doesn't have a lot of resources but wants to use that, especially if they're familiar with R. They might even have their statistics or analytical code in R. So it's just a logical extension of that, and I think it's free and open source, so that's always a bonus. We like that too.
So I have a little bit of a biased take on this as a custom app builder, and I'm not an R coder, so I can't speak to this as someone who builds these. But from a usability standpoint, I think our Shiny apps can sometimes run into scaling issues when a lot of people hit them at the same time. I think they work really well when you're targeting specific small audiences who don't mind a little bit of spin up time for the R Shiny app to come online and be interactive. And maybe they're more used to the specific widgets and way that you would drive an R Shiny app. For something that's more targeted towards the public and potentially getting high traffic, I would feel a little bit more cautious.
All right. Thanks, guys.
Yeah, thank you for that. Cheers.
All right. Any other questions out there? We have time for a couple more questions, if they're out there. Going once. Going twice. All right. I think that's it then. I think we've answered all the questions that they've got for us today. And thanks so much, all of our presenters. I'm going to pass it back to Nancy to wrap up today's webinar.
And thank you all for attending and for the great detailed talks. I know they were very informative from my perspective, and I'm sure from the folks I work with as well at Pacific State. We did record today's webinar, and the video will be posted to PNAP's YouTube channel in the next couple of days, and you can get access to the links to that video from the PNAP website on their ETIS landing page. And if you want to know more about PNAP's upcoming events, you can keep track of those events either on the PNAP website or by the PNAP's monthly PNAP's monthly newsletter. And if you aren't already on the newsletter, you can access the link that Amy just dropped so that you can join that newsletter. We'll also be posting other updates on the ETIS landing page, so feel free to consult that and join any meetings or webinars that might catch your fancy. So I just want to point out that we have our last data management webinar next Thursday at 1 p.m. and we'll have two presenters. The first will be presenting on tools and best practices for data sharing and reuse to advance research. The other will be presenting ethics of data sharing in the environmental sciences. And if you want to learn even more about data visualization, PNAP also works collaboratively with USGS CDI Data Viz group, which also hosts webinars, and they have a webinar scheduled for March 18th at 11 a.m. Pacific time on how data journalists think about data, and that's also public and free. So you can access information on that webinar from the link that Amy just dropped in the chat. And that concludes today's webinar. Thank you for sticking around to the end, and have a great day.